Hey, Algebra 2, back for another video. Closing in on the end of the videos for this year and being done with Algebra 2. Now we're going to be working on the hyperbola. So far, if you've been watching these videos, we've talked about the circle and the parabola and the ellipse. All of those can be done by using one cone. And on the next lesson, we're going to be talking about how cones create all these, a little bit more detail. But if you could picture, you have to actually really picture two cones in order to picture all the conical sections. There's an axis that goes down these cones. Again, we'll talk about this tomorrow. But if you were to take a slice down just like that, you're going to end up with a hyperbola, which is like an ellipse that has been inverted. So like picture taking this ellipse that we have, slicing it down the middle and making mirror image at each one of those points. So going like out here and out here. Just there's nothing to stop it to the left and to the right, so it keeps going and keeps going. That's a hyperbola. And what causes that action to happen is this negative in the equation. The hyperbola is so close to the ellipse. You got to be very careful, because the big difference about a hyperbola and an ellipse is that negative. Now, again, HK is the center, but when we go to find the foci, we are going to use the equation a squared plus b squared equals c squared. Like I mentioned in the ellipse video, it's one of the things you're going to want to have as you come into this test. This is a note card it ought to have this on it. It ought to have the definition of a hyperbola on it. It ought to have these equations to find the foci and the focus and the directrix and all that stuff for each one. It's going to be very useful for you when it comes time for the test. So here, I know this looks like kind of a crazy thing, but this is how we're going to determine the hyperbola, how we're going to graph it. We have our focus. Now the focus is inside the hyperbola, so it's inside the graph. So if I'm going to highlight the hyperbola, the actual hyperbola, and it's right here. See, this is the hyperbola. So it's inside the curve. It is concave in the curve, okay? It's not on the outside. So that's where the focus is. And if A, you could see on this case, A just goes to the vertex of the hyperbola. The focus extends beyond that. Well, that's why c squared has to be greater than a squared. And we're gonna find we're also going to learn how to find these lines here, these oblique lines that are going to determine, because they determine an asymptote that this hyperbola is going to get closer and closer to, but never going to reach. Okay, so those are some of our goals for today. So here I got an equation. It's pretty simple, pretty straightforward hyperbola. Just to get us started, the first thing that I want to do is I want to locate the center of this guy. So the center of this is at 0, 0, 0, 0 right there. The center. And now I want to find my major axis and my minor axis. Very similar to the ellipse. The greater one is going to be the major axis. So under y squared, you got a squared equals 48 and b squared equals 32, and that's the minor. And this is the major. Okay, now, but again, when we begin looking at this, a hyperbola can either go like this, open horizontally, or it can go like this, like open vertically. The difference between the two, how you know which one's which, depends upon what value comes first. So if it's x squared minus y squared equals 1, then it opens horizontally. If it's y squared minus x squared equals 1, then they open vertically. Does that make sense? So in this problem, are they going to open horizontally or are they going to open vertically? If you said horizontally, you'd be right because x comes first. Okay, so now we want to find the values for a and b. So if a squared equals 32, then a equals plus or minus the square root of 32, which is actually a equals plus or minus, let's see, that's 4 root 2. But that doesn't help us very much, does it? I'd like an approximation as I go to graph this. So the approximation is going to be 5.65. A equals plus or minus 5.65. So in the x direction, I'm going to go 5.65, 5.65 in the x direction. Now I'm going to go in the y direction, and I'm going to figure out what that's going to be. So I'll take b squared, which is equal to 48. So b equals plus or minus the square root of 48. I know I like to rationalize stuff and have it there. So when I rationalize that, it's let's see, 16 times 3, right? Is 48. Yep. And so it's 4 root 3. Oh, we did this earlier. It's b equals plus or minus 6.9. I remember that. So we're going to go up 6.9. 6.9 kind of goes off my graph, but not too far. Okay, now what that does is that you saw on the last slide, see how there's like this strange box here? That box was created by the major and minor axis. So I'm going to come right over here. I'm going to do the same thing. I'm going to go up and then perpendicular to my axis and then over, perpendicular to my axis. Oops, I switched A and B, but actually in a hyperbola, that hasn't really hurt anything that I've done. You can switch the major and minor axis in this case on a hyperbola. Okay, so that creates that box that you saw on that other slide. Now, the next thing that happens is I have these oblique asymptotes that we can create. The oblique asymptotes go from one corner of my box through the center down through the other corner of the box. Sorry, I didn't get that straight as I ought to. And then I've got another one that's going to go straight down through there. So that's a straight line. So if we wanted to, and we will, I believe later on in this lesson, we can find the equation of that line because it's found by y equals mx plus b. And b can be found by the y-intercept, which in this case is 0. And m can be found by rise over run. And you got a right triangle right there that's going to allow you. Here, let me get my laser pointer out here so I can show you. You got a right triangle right over that right here, which it's going to tell you change in y, change in x. And so I believe this change in x is square root 32, and this is square root 48. Now watch what happens if we did rise over run. It would be actually it's going to be 4 root 3 over 4 root 2. So actually, it's square root of 3 over square root of 2x would be the equation of my line. I didn't really have to do that. I've never actually done that on this slide before, I don't think, in my years of teaching this. But anyways, so now as I go to graph this, it opens horizontally, so these points become very, very important. And it's going to go towards those asymptotes and get closer and closer to them without actually touching them. So that's how I'm going to sketch my hyperbola. All right. Last thing to find is the coordinates of the foci. So you got a squared plus b squared equals c squared. This time you're still going to use 32 and 48 as a squared and b squared. Makes our lives a little bit easier because we got 80 is c squared. So when it opens horizontally, so just like last slide, start with the center. Then if it opens horizontally, that means it'd be equals plus or minus the square root of 80, which you could reduce. 80 divided by 16 is 4 root 5. So it'd be plus or minus 4 root 5. 0 is my foci. And that's approximately, if we said the square root of 80 is approximately 8.9. So that means I'd come out here 8.9. So that's 6, 7, 8, 9. 8.9. And way out here, 8.9. So the distance from the center to the focal point is 8.9 units. All right, let's move forward. Here's another one. This time the center, the vertex, the center has changed. So instead of 0, 0, it's at 3, negative 1. 3 over, negative 1 down. Now I could take my major axis, what travels, this one is going to open like this because y leads. Last one x leads, so it opened like this, opened left and right. This time y leads, so it's going to open vertical. Okay, so my major axis, which is going to be the y, change in y, is going to be a squared equals 36. A equals plus or minus 6. So I'll have a major axis at 6 and negative 6. Minor axis, b squared, is at 25. So b equals plus or minus 5. So go over 5. Oh, excuse me. I got so used to going from 0, 0, but this one isn't at 0, 0, is it? I have to go, if we're going up 6 and down 6, it's got to be up 6 from the center and down 6 from the center. So I had to move up 6 like this, go from here up 1, 2, 3, 4, 5, 6, and down 6, 1, 2, 3, 4, 5, 6. So then I have to move from the center, the vertex, out 1, 2, 3, 4, 5 units, and out 1, 2, 3, 4, 5. And they just happen to go off of my page again. All right, so that allows me to create that little box again. Remember, oops, get out of orange highlighter. So I can use those points because they lie in my box. So I just use those points that I have to create the box. Then once I've created the box, I can do my oblique asymptotes, which go off the page. Okay, so those are the oblique asymptotes. And when I do the graph, it's vertical, so I start here and here. I'm not going to get down on the bottom, but up here it's going to go out towards those oblique asymptotes, and the same thing would happen on the bottom. It would go like that and like that. Okay. So if I were to find the foci, it's a squared plus b squared equals c squared. So we got 36 and 25 equals c squared. So that's going to be 61 equals c squared. So c equals plus or minus the square root of 61. Square root of 61 is approximately 7.8. Approximately 7.8. So that means from my center, I'm going to go up 1, 3, 4, 5, 6, 7.8. That's where one of my foci are. The other one is going to be 7.8 down, but it ends up off the screen. So just so you kind of go, I started here at the vertex and went up 1, 2, 3, 4, 5, 6, 7, almost 8, and that's how I found my foci. So if I want to find the coordinates of it, again, I'll start with my vertex, which is at my vertex, clean this up a little bit. My vertex is at 3. Oh, give me all sorts of troubles. 3 and negative 1. Now it opens vertically. So that means I'm going to add and subtract it to the y. So it's going to be plus or minus square root of 61. So then I can clean it up. 3, negative 1, plus or minus the square root of 61 is the coordinates of the foci. All right, let's keep moving forward. Oh boy, what's wrong with this one? Well, if we've been paying attention, we know that this doesn't equal 1, and a hyperbola doesn't equal 1. Now, all hyperbolas have to equal 1, so we want it to equal 1. So just like on the ellipse, we're going to divide by 100, divide by 100, and divide by 100. So we'll get x squared over 100 minus y squared over 25 equals 1. So my vertex is at 0, 0, and it's going to open. Is it going to open horizontally or vertically? I'm asking you. I know, but I'm going to write it down in a minute, but I want you to know. Is it going to be horizontal or vertical? Well, here's the answer. It's going to be, you guessed it, horizontal. The reason it's horizontal is because x squared comes first. Okay? So the major axis, a squared, which travels on the x-axis because it's under x, is 100. So a equals plus or minus 10. Not going to fit on my graph. B squared equals 25. So b equals plus or minus 5. Okay, so I'd be going up 5, down 5. I should have put a different graph on here. Out 10 and 10. We're just going to pretend that this is at 10, and then that would create my box. Making my box. It has to contain all those major axes and minor axes perpendicular to the center, which is at 0, 0, which gives me those oblique asymptotes, which pass through there, through the center, and out the other side, through there, through the center, and out the other side. Now I'm only going to get one of these sides of my parabola again, but you should have two sides, but that ends up off the page on the other side. Goes down towards the oblique asymptote and towards the oblique asymptote. that have the same thing on the other side. You know, it's going to look like this, but you got to start at that green dot. Okay? So, foci found by a squared plus b squared equals c squared. A squared is 100, b squared is 25, so c squared equals 125. So c equals, let's see, that's 5 square roots of 5, plus or minus. And it travels in the x, so it's going to be 0 plus, not a comma, 0 plus or minus 5 square roots of 5, 0. Or just plus or minus 5 root 5, 0. That one was a little bit fast. I did that one a little bit faster than I have been doing other ones. Just so you know, I didn't quite take my time here. So here we go. We got another one again. Again, it does not equal 0, so equal 1. We want it to equal 1. So we're going to divide by 324. And it's very nice that I think about this and I go 4 plus 2 is 6. 6 plus 3 is 9. So divisibility rules tell me that everything here is divisible by 9. That's going to be very, very nice because when I divide by 324 and I divide by 324, the bottom's going to become cute. That doesn't mean that it has to happen that way, but because we're in 11th grade algebra and they want to be kind to you, it's going to happen that way, okay? So you got 324 divided by 9 equals, oh, look at that, 36. So the equation that we end up with, the reduced equation, is going to be y minus 2 squared over 9 minus x plus 1 all squared over 36 equals 1. That's my graphing equation, all right? My vertex is 2, negative 1. 2, negative 1. All right, major axis is going to be in the y, so that's going to travel vertically. And it's a squared equals 9, so a equals plus or minus 3. Horizontally is b squared equals 36. B equals plus or minus 6. And so that's going to allow us to find the coordinates of our graph. So this will fit on my graph, so I'm very happy about that. This is going to open vertically, like this. And the reason for that, the reason it's going to look like, let me get the right color here, that, then is because y leads first, okay? So when I put those points in, I get positive 3 up, negative 3 down, and I go negative 6 to the right, and positive 6 to the left. And I know I said that backwards, but that works. So now we create our box that's going to determine the shape of this hyperbola. So it has to contain all those points. It has to be a rectangular box. So that will determine the box. And then that will allow me to find the oblique asymptotes. I think there's a few problems in the lesson, I know, where it wants you to find the equation of those oblique lines. And I'm pretty certain, because I can't see you in person, that I'm going to say don't worry about those this year. But I'd like to explain to you that, again, this one, the equation would be in y equals mx plus b form. And we know how to find the equation of a line. The y-intercept is 0. And the slope is we're changing 6 over and 3 up. So, excuse me, 3 up. I hate it when it does that. I don't know why sometimes. Y equals rise over run. I just took 3 over 6 and I said 3 over 6 equals 1/2. So that's how I got the equation y equals 1/2 x. I'm letting you know because it's part of the lesson. It's something that's in the textbook, but I don't think I'm actually going to have you determine the equations of those lines this year. Okay? All right, so this opens up. We decided that a while ago. I highlighted it here because of here. So I go to this point, and they travel towards those oblique lines. The purpose of those oblique lines is they provide an asymptote that this graph is going to go towards without ever touching. Okay, that's what the hyperbola looks like. The foci is found by a squared plus b squared equals c squared. We got 36 and 9 equals c squared, so 45 equals c squared, so c equals 3 root 5, plus or minus. So approximately, I'm guessing it's going to be like 6.5. So we'll do square root of 45 equals 6.7. I was close. 6 plus or minus 6.7. So I go from my points, my vertices on the parabola, and I go up 6.7, find a foci, and I go down 6.7 to find a foci. Let me show you again with a laser pointer how I determine those points. I started at the center, and I go up 1, 2, 3, 4, 5, 6.7. Down 1, 2, 3, 4, 5, 6.7. So if I were to determine the coordinates, it's 0, and because it changes in the vertical, plus or minus 3 root 5. Okay. All right. I think, what are we looking at here? Oh, whoa, 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 whoa. Okay, 3 more slides, I guess. I thought we were getting close to the end. Yeah, let's get going, I guess. If we were graphing this, we have 4, 1, and negative 4, 1, 6, 1, and negative 6, 1. Well, where would the middle be? Like, you should be able to figure that out. The middle's right here. Okay, check this out. 1, 2, 3, 4. 1, 2, 3, 4. Right? So that's the middle of this equation. So I'm thinking that the center of this guy is going to be at 0, 1. That's important. Now, also, I know that's going to go something like this. And I'm going to erase these in just a minute. How do I know it's going to be something like that? Well, the foci is always inside the curve. The foci are always inside the curve. I explained that already. So I know that x is going to come first up here. So it's going to be x squared. And then there's going to be a minus y minus 1 squared. You say, how'd you get to minus 1, Mr. Wilson? Right here. And remember, h and k lie in a hyperbola. So that's how I got that value. All right, it's going to equal, what do all these in graphing form equal? 1. Now I'm going to find x and y. X, I know what x is going to be. What's going to be under x? It's going to be, it's 4 units. 1, 2, 3, 4 to the graph. So that would be a. So a squared. So if a equals 4, a squared equals 16. And because we know that it opens up because of the point of the vertex, I know that this is going to be 16. All right, so now I want to calculate where the minor axis is going to be, and we know that a squared plus b squared equals c squared. And we've got from here, this is c equals 6, so c squared equals 36. So this is 36, this is 16, so a squared is going to equal 20. So that means I can put 20 right there. I'm done. That wasn't too bad. Oh, we got to graph it too. So that means a is at plus or minus the square root of 20. A equals plus or minus the square root of 20. And I'm guessing the square root of 20 is a little bit less than 4.5. Let me try on my calculator. Square root of 20 is 4.4. We've done that today already. I should have remembered, or maybe it was yesterday. I don't remember. Days all kind of run together for me now. All right, so there's A is approximately 4.5. So that means I could go up 4.5, go down 4.5. That's going to allow me to create my box. Whoop. Didn't quite get my box right there. Okay. Now once I got the box, actually, oops, I gotta fix it. I made a mistake. My mistake is at that point right there. I gotta go from the center down, and actually it's wrong on the top too, isn't it? I went from 0, 0. So we gotta fix that. Because we gotta go up 1, 2, 3, 4.5, not to 4.5 up. And we gotta go down 1, 2, 3, 4.5. Let me show you what mistake I made. I went, I'm gonna get my laser pointer out here. I went to 4.5 up and 4.5 down. And all of a sudden it's looking strange, but I gotta actually go from the center. 1, 2, 3, 4.5. 1, 2, 3, 4.5. Sometimes we learn the most when we make a mistake. So we go from the center. 1, 2, 3, 4.5. 1, 2, 4.5. So I'm glad I can make that mistake and we can go back and fix the error. So now we get our highlighter out and we make our little box. My box is coming out nicer this time. I'm happy about that. Now I have oblique asymptotes. They have to go through the graph, through the center, down through the bottom, through the graph, through the center, down through the bottom. I could calculate the y equals mx plus b. B in that case would equal 1. But in finishing off the graph, these are going to go shoo, 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 and shoo, whoa, shoo, like that. And this actually is the hyperbola graph that I like the best that we've had in the homework today. So it fit the nicest on. It's hard to get hyperbolas that can fit on a graph that's really going to show you stuff. This is the same problem, and I know this video has been going on a while, so I'm going to skip this one, and we're going to move on to the next one. So this problem is just about the same as that one there. So these two are about the same. So for time's sake, I'm going to skip that. This one, it says find the equation given the information that you got. So the center right here is at the coordinates -3, +3. Okay. So now I have the box, which is going to allow me to find A and B. And so if I look at the box here, I can count over, get out my laser pointer. It opens in the X direction. I'm going to go back here and I'm going to say, I know that's going to be X and then Y, and it's going to equal 1, right? Because of the way that it opens. So then I get out my laser pointer, I go over 1, 2, 3, 4. And again, this way, 1, 2, 3, 4. So A equals 4. So A squared equals 16. And that goes under X. And we know that this is positive 3 because of right there. And so then I can take I'm going to take my laser pointer again. I'm going to count 1, 2, 3. 1, 2, 3. See the box? 1, 2, 3. 1, 2, 3. So the minor axis, it's going to be 3. So B squared equals 9. So that goes under here, 9. And this is Y minus 3 squared. So the only thing I have left to find is to find the focus. So that's found by A squared plus B squared equals C squared. And we have 16 and 9 equals C squared. Put them together, you get 25 equals C squared. So C equals 5. Okay, so C equals 5. We're going to go over like this from our center. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So it just happens to be so nice and cute. So it's right there and right there. Those are my foci. Foci. Well, I guess this is a focus and that's a focus. But anyways, foci and foci. Okay. So the coordinates of those are at -8, 3, and 2, 3. And we've got -7, 3, and 1, 3. All right. Whew, here's the homework. Wow, that was a long lesson. And let's see what we want. I want 1. I want 4 to 6. So there's 1, 4, 5, and 6. There's 4 questions. Sure, 13 and 14 don't look too bad. And I like 22 and 23. 22 and 23. So that's 1, 2, 3, 4, 5, 6, 7, 8. So don't have to worry about doing number 9 or 19 or anything past 23. So, okay. All right. Have a good day.